LeetCode problem number 17, letter combinations of a phone number, Java solution. But before we discuss, please like, share, subscribe, and hit the bell button for notifications. Also, I have added a lot of quizzes to the posts page. Please check it out. Now, back to the problem. Like you are given a phone number and you are supposed to come up with all the letter combinations, like this one, like 1 2 3 has 2 has ABC, and then D E F G H I. So you need to, like, this has practical application. Like if you want a number like 1-800 Apple for people to remember for Apple's customer service, now you need to figure out like which phone numbers are available and which phone numbers will map into 1-800 Apple kind of thing. So for that purposes this can be used. And so for example, this is not a practical example because this is just because there are so many combinations. So the test case is very simple. In the case of 2 3, 2 has ABC and then 3 has DEF. So the combinations are AD, AE, AF, and then similarly BD, BE, and BF, and then CD, CE, and CF. So this is what you should output, all the combinations. So you basically get a phone number and then get all the digits, and then see if you take out the 1-800 and then you just take the last 7 digits and then run this program and then see which matches closely to your company's customer service phone number. So let us take a look at the Java solution. So this is you define a static map. This is because this is a constant. Like every phone number has the same mapping, so you put it in a phone map. Now you have this function. We use the backtracking solution to solve this problem, because whenever you need combinations, then backtracking is the way. It is almost similar to the recursive solution. And so you start off with the string of digits like 2 3 in the case of that LeetCode example. Now in the case of backtracking, you have a result string to capture all the results which satisfy a certain condition, and then you have a running pattern or a string for the backtracking thing, and then you have 2 parameters or additional parameters. In this case usually it is 4 I have seen, but total parameters, but it can be more. These are the like the additional parameters you move around, so that this is like an index. So you keep moving the index like A, and then you move the index to 1, and when it is 0 it is A, and then in the case of 2 3, in the case of 2 it is the index is 0, and then in the case of 3 it is index is 1. So that is that index. And so you capture the results in the Java array list, and you make sure this is a base case verification, and then immediately you call the backtrack with the result to capture each of the combinations, and a string builder, because you don't want to use the string because strings are immutable in Java. So you want to do the string builder so that you can add and remove from the strings as and when you expand and backtrack, so to speak. And then the digits you keep passing around. This is a constant. I don't think this gets modified, but this one is the index, the pointer within the digits where it is, and that's why this one gets modified. So let us take a look at the backtrack solution. It's a recursive function, and when you, this is the condition, like recursive in the case of recursion, you, when you factorial or something, when you shrink, the base condition is the when you reach the factorial of to 0, then it will return 1 kind of thing. So it's here in this case, when you hit the total length of the digits, like 2 3, like in this case the first thing is 80, when you match, that's when you add it to the result, and then you return from that specific recursive stack. But if you see, you get the letters from the phone map for the digits, which is digits is 2 3 and the specific index. So in the case of 2, it is 0. So initially you start off with 0. So at index 0 for digits is 2, and then you go and map for 2, it is ABC. So the letters initially will be ABC, and as you go through the iterate through the letters ABC one by one, then you append, this is the current running string, so you append the current thing, so combination becomes A, and then now you backtrack the combination. Once again you call into the function with index plus 1. So when index plus 1, it moves to 3 basically in this case. So here index is 0, and now it is 1. It is still not equals to the length. The length is 2, and so you come back here, and then now in the case of digits at character 1, it is 3, and for 3 it is DEF. So you get the letters as DEF in this specific recursive stack, and then you go through the DEF array, and then you add the letter D, and then you backtrack again. Index plus 1. Index plus 1 is 2, but the combination now is AD, and then you come here again. Now it matches. So it becomes AD is the combination, and then you return from that specific, this is the second call to the backtrack function if you exclude this one. And I think it include this one also. It is the second call. Now you delete the D character. So you delete the D character again. Now you are looping through the ABC, DEF, you are looping through. Then you pick up the letter E, and then once again backtrack, and at that point you add AE to the result. So this is how it is going to work. We can take a look at the run as well. And so at the end of it, you final return, you return the result string. So there are lots of internal backtrack calls, which is basically adding this result, and this is how you are going to get all the combinations. So let us take a look at this specific run for 2 3 digits is 2. So for the letters is ABC, the map is ABC. So you add A to the combination. Now you go through D, and then letters is DEF, and then adding D to the combination letter D, and then it becomes AD, and that's what you added combination, because you hit the length of 2 for 2 3. And so you remove D from AD, and then you make it into AE, and then you remove E, and then you make it into F. So that's how it proceeds. And then later on you pick up B, and then later once again go through D, E, F, and then pick up C, and then go through D, E, F, and then that's how you exhaust all the combinations, and finally you'll end up with this result set. That's it. Comment below if you have any questions. Otherwise, I will see you in the next video.